Hello, everyone. Thank you for joining this broadcast. My name is Navtanesina, and I'm a senior product manager with Amazon Neptune. Today, I will walk you through a modern data strategy for building applications. We will talk about graph databases and common use cases for those graph databases. I'll introduce you to Amazon Neptune and cover some of our recent innovations. I will also do a demo of the product at the end of the presentation so that you can see Neptune live in action. Now, as customers move their data to the cloud, they are also rethinking about how they are building their applications. For example, take an application where millions of users are buying things online. Developers are building their applications with microservices architectures, allowing them to break larger applications into smaller services and picking the right database for the right job. You can have an application where your search function uses Elasticsearch for quick search results, your transactions supported by a relational database, customer reviews supported by key value database for performance, and your recommended items using a graph database because it can store relationships in data and find connections quickly. A modern data strategy gives you the best of both data lakes and purpose-built data stores. It enables you to store data of any amount at low cost in an open standards format. It lets you break down data silos and allows your teams to run analytics and machine learning using the tools that they prefer. And also manages access to the data with proper governance and security policies. Move and store any amount of data from various silos into an Amazon S3 data lake in an open data format. An S3 data lake gives you unmatched scalability, reliability, security, governance capabilities at a cost-effective manner. AWS provides the broadest and deepest sets of purpose-built data stores optimized to give you the best-in-class performance for the functionality of your workload. With AWS, you can use the right tool for the right job so you don't have to compromise on functionality, performance, scale, or cost. You can access data seamlessly and easily keep it in sync regardless of where it lives. This provides you with unified governance for centrally defining and managing security policies and gives you AI and ML capabilities to solve business challenges across services. Now, instead of looking at multiple different databases for your architecture, we should be thinking about common database categories and what problems they solve. This visual provides a simple mental model to help us understand which use cases are addressed with which database. If you have a use case that requires structured tables, transactionally heavy workloads, you would use a relational database such as RDS or Aurora. Similarly, if you have a database that optimizes running key value pairs at a high speed and large scale, DynamoDB is a good fit for you. Now, let's say you have a large data set with a lot of interconnections, and you need to run fast queries over all these connections to get recommendations, detect fraud, resolve identities. You would use a graph database such as Amazon Neptune to query and work with these highly connected datasets. For this presentation, let's review Amazon Neptune for data that is interconnected and can be represented as a graph. But first, let's talk about what a graph is. Graphs are everywhere. Graphs are a data model that consists of nodes and links, sometimes called edges and vertices. They are great for storing relationships between data because the edges can be queried directly. They represent relationships between things and tell us how things are connected to each other. If you can draw a picture of your data like a network on a whiteboard using circles and lines to show how everything is related to each other, then you have a graph use case. Customers ask us when to use a graph database. You should use a graph database when you have relationships in your data and you want to ask questions traversing those relationships or expressing patterns over them. Using a graph database for these scenarios helps you answer questions faster and in a simpler manner. A graph database is optimized for storing and retrieving graph data and supports query languages and APIs that are designed for asking questions over the relationships. So, what kind of problems are customers solving with graphs? Some of the common use cases involve mining your data for knowledge, retrieving identities, detecting fraud, and ensuring the security of your IT infrastructure. A knowledge graph helps you bring together various data sources in your organization and links them together to answer questions in your data and helps you answer these questions in a much simpler and easier format. Knowledge graphs make it possible to discover hidden connections in your data and improve your search results. Identity graphs, which are sometimes also referred to as customer 360 graphs, help create a persistent identifier for an entity or a customer to link all related devices and IDs. It enables a unique profile creation for that entity, which helps organizations with targeted marketing or personalization. Fraud graphs help locate and prevent fraudulent patterns of transactions, such as one household using multiple credit cards, or maybe one person with many different identities. And security graphs help detect threats to your environment, such as uncovering unwanted access to applications or exposed IT resources which may be accessed from outside your organization. Now, let's look at a database to help you with these use cases. Amazon Neptune. Amazon Neptune is a fast, reliable, fully managed database that makes it easy to build and run applications that work with highly connected datasets. The core of Neptune is a purpose-built, high-performance graph data engine that is optimized for storing billions of relationships and querying the graph with milliseconds of latency. Amazon Neptune supports popular graph models, Property Graph and W3C's RDF, and their respective query languages, Gremlin and openCypher for Property Graph and Sparkle for RDF, allowing you to easily build queries to effectively navigate highly connected datasets. Neptune is highly available with read replicas, point-in-time recovery, continuous backup to S3, and replication across availability zones and AWS regions. Neptune is secure with support for HTTPS encrypted client connections and encryption at rest. It is also fully managed, so that you no longer have to worry about database management tasks such as hardware provisioning, software patching, setup, configurations, backups, and such. Since our launch, we have worked backwards from the feedback that customers have provided us to add functionalities to Neptune that would increase performance and reduce costs, make it even more enterprise ready, and integrate it with other AWS services and technologies to further help use cases that Neptune solves. Let's go and have a closer look at some of these launches. Neptune full text search integration. You can use Neptune's integration with Amazon OpenSearch to perform full text search in your graph data. This helps you quickly find dates, numbers, texts, and even more with your Neptune data using an OpenSearch index. To perform full text searches, you would enable Neptune Streams, our change data capture feature, and publish records to OpenSearch using Streams. Then you can easily query OpenSearch from Neptune and use any of the graph query languages to perform full text searches. We also released a Python package for Jupyter Notebooks to support graph visualization. Since it's an open source and available in GitHub, you can use it for any graph database that uses an openCypher, Gremlin, or Sparkle endpoint. You can use this notebook to visualize your graph queries, group results, present them with customizations, drill down into any of the node to see the labels, and even more. We will soon be seeing this notebook in action during our demo after this presentation. We released Neptune machine learning capabilities to make better predictions with your graph data. Neptune ML is an integration with graph neural networks powered by Deep Graph Library and Amazon SageMaker to make easy and quick predictions with your graph data without the need to have expertise in Neptune ML, machine learning techniques, and models. You can automatically choose and train the best ML models for your workloads or bring in custom models and get up to 50% more accurate results in hours instead of weeks. Earlier this year, we introduced openCypher as a generally available query language for property graphs. openCypher is a declarative query language that is intuitive to understand, as it allows customers to draw on their SQL knowledge to get started with graphs. Our support for openCypher is interoperable with Gremlin so that you can use both query languages over the same graph dataset without the need to choose one or the other. Also, we started supporting Bolt, a protocol used by graph databases that use openCypher. So if you already have applications using openCypher and Bolt, you can easily connect to Neptune without the need to refactor the applications. We launched an open source integration with Python to simplify the workflow of running graph algorithms with your graph data stored in Neptune. You can use any Python client for this integration: Jupyter Notebooks, AWS Lambda, EC2 containers, or directly from Neptune notebooks. To get started, use the Python integration to pull your graph data into a pandas data frame. Then use your favorite open source library like iGraph, NetworkX, or QGraph to run algorithms like PageRank, connected components, and even more. Furthermore, to get started with analytics, we have published two tutorials, one for fraud detection and the other for customer 360 applications, so that you can easily follow along. In our latest release, we introduced fine-grained access control for data plane actions when you use IAM to connect to Neptune. This allows us to control access to more than 35 data plane APIs, restricting actions such as writing to the graph or deleting data from the graph for the users who don't need it. All you need to do is enable IAM authentication on Neptune engine release version 1.2 and start using fine-grained access controls. To help you get started, we've also published separate policies to provide access to any data plane API. In July of this year, we introduced Neptune Global Database, a feature that helps you deploy Neptune clusters across multiple AWS regions for fast cross-region replication for use cases such as disaster recovery or low latency global reads. You can have one Neptune cluster in your primary AWS region, replicating to as many as 5 different Neptune clusters in secondary AWS regions. Replication is handled by a dedicated replication layer for low lag and fast replication between the clusters. In the event of an unlikely regional outage, you can quickly promote one of your secondary Neptune clusters to primary and continue with your applications with minimum downtime. And to help you get started with Neptune, we've also introduced a free trial offer. If you are completely new to Neptune, you can get up to a month of free usage to test your workloads before expanding your Neptune footprint. You can get up to 750 hours of compute storage, 10 million IO requests, and 1 GB storage and backup each to test if graph databases is the right fit for you. Before we go into the demo, let's recap some of our recent innovations. We spoke about general availability of openCypher, global databases, fine-grained access control, full-text search integration, Neptune ML, and our analytics with Python. But we have also doubled our storage cap to 128 terabytes to support even bigger graphs. We've also added capabilities to improve uptime in case of cluster restarts, where the read replica actively accepts read requests when the writer instance restarts. Also, Neptune is now in scope for FedRAMP compliance, both high and moderate, for all the US AWS regions that we support. And we also added support for global condition keys so that you can use the condition field of your IAM policies to restrict access to users, such as from a particular IP address or from a particular region. Some resources to help you get started. You can review the notebooks released with analytics tutorials, review our user guide and release notes for the latest and greatest on Neptune, and visit our free trials FAQ page to get even more information about it. Now, let's move on to the demo, where I'll be showing you how to create a secondary region for a Neptune global database, load data into the Neptune global database, and query data from both the primary and secondary regions to show you how replication works. So for the demo part of the presentation, let's begin at the AWS Management Console. You will select services, navigate to databases, and navigate to Amazon Neptune to enter the Neptune Management Console. In the Neptune Management Console, you'll notice that I have a few databases already created. These are single cluster databases which have writer nodes and reader nodes to it to write data and read and accept queries for Neptune from there. We are going to use one of these databases to begin our demo. Let's begin with Naftali Cluster 1 as the database to convert into a global database. To convert this database into a global database, I select the radio button next to the database, go to Actions, and select Add AWS Region. I have a few options over here that I need to fill out before I add an AWS region and make this database as a global database, which is what will be my global database identifier name, which is my global database name, right? So I'm just going to call it global DB1. And then I will select the AWS region where my secondary cluster will reside. As you can see, I have a choice of 6 AWS regions to select from, and that's because global database is supported in 7 AWS regions, out of which North Virginia is where my primary cluster already exists. For the purpose of this demo, let's select US West, Oregon region for my secondary AWS cluster. I will select the kind of instance I want to create, which is my R6G XL instance, same as my primary cluster. I'll select multi-AZ deployment so that I get 2 clusters for high availability. And then I will open the additional configuration pieces to make sure that the cluster names that I want are the same. So just to show you what naming conventions we use for our secondary cluster, I'm going to alter the name a little bit so that you can see it when the database is created. With all the other default options, I'll click on Add Region to create my secondary database and make my global database setup functional. As you can see, this command has introduced a global DB1 as the global database, which has 2 clusters. One is a primary cluster and one is a secondary cluster. The primary cluster has 2 nodes, a writer node and a reader node. And the secondary cluster has 2 reader nodes because this is a read-only cluster accepting replication from the primary cluster and available for read queries. As you can see, in a couple of minutes, we have the secondary cluster available and the reader nodes are being created. It'll take a couple of more minutes for the reader nodes to be available. In the meantime, let's go to Neptune notebooks and connect a notebook to my primary cluster to begin loading data and querying the data. Navigate to the left panel where there is a notebooks link, and you will see that I have a notebook already created that I'm going to use to connect to my Neptune cluster. At this point, this notebook points to a different Neptune cluster, but we will change the endpoint to make it point to our primary AWS cluster. Let's open the notebook, which takes us into Amazon SageMaker. And we go into Neptune. And what you'll notice is we have a few tutorials to help you get started with Neptune in any of the notebooks that you create. It'll have a getting started tutorial, some tutorials for visualization, some sample applications that you can follow along, machine learning applications, data science applications, and language tutorials to help you get started with the 3 languages that we support. For the purpose of this demo, we'll go into visualization and select openCypher, as that is the language that I'll be using for the demo. When I open the notebook, the first thing I see is a visual which represents the data set that I will be using for my demo. This data set is what we call an air routes dataset, which contains all the airports of this world and all the flight routes that connect those airports. As you can see, it is really well represented as a graph, with the green dots representing all the airports and the orange lines the flight routes. The first thing I do is I change the endpoint to point my notebook to the primary cluster. For this, I will run the command graph notebook host and my host name here. To get the host name, I should go back to the primary cluster, which is my Naftane cluster 1, and select the writer endpoint because I'll be writing data into this cluster. So I will just copy the writer endpoint from here, go into my notebook again, and replace your hostname here with my writer endpoint. And then all I have to do is run this command, and my hostname is set to my primary cluster. Let's see the configuration of my database. You would see that my hostname is set to my primary cluster, and all the rest are the default configurations, and the AWS region is US East 1. Let's check the health of my database by a status command. You'll see that my database is healthy right now, and a bunch of other options that you can select, such as enabling object index for lab mode or IAM authentication features, which is currently disabled. You can enable it to connect to Neptune via IAM. Now, before we load data, let's go back and see whether my database is created for the secondary database or not. In my main AWS Neptune console, I can now see that my global database is created and it has a primary cluster and a secondary cluster with all nodes available. To take you to the secondary cluster, you would see it navigates into a different AWS region. In this case, the AWS Oregon region, which is your US West 2 region, where my cluster names are represented and I have two endpoints available. You'd see that the first endpoint, which is the writer endpoint, is inactive at the moment because at this moment, this cluster is a secondary cluster. And the reader endpoint is available to accept queries for the graph. Now let's go back to the notebook. Let's seed some data into this notebook. And for that, I run the seed command and I select the property graph data that I want to select since I'm using openCypher. And I select the airports data set to load. And all I have to do is submit, and my bulk load of my airports data set has started. It'll take a few seconds to finish. While I'm loading this data, let's look at what we can do with this data. You can use openCypher to visualize your queries, and we have published this tutorial for all to see so that you can use commands such as openCypher city and list all the cities, or commands such as matching the nodes and returning 5 or 10 or 15 first airports that we see. So let's make this 10 airports so that we can see the first 10 airports that are returned. Let's see whether our data is loaded first or not. You can see that my data loading is done. So let's run this command. And this command uses openCypher to fetch the first 10 airports in my data set. I run this command and I can see a graph of 10 airports right now, not how they are connected because we have not run that command, and we will run this in the next few queries that we run. But to look at the airports, we can look at the JSON result and see which airports are returned. You can see airport identities such as Kolkata Airport or Nairobi Airport or the Durban Airport being returned as a command. Let's see what commands we can run to find routes between airports and how they are connected to each other. We are going to use These commands helps you find the routes from Austin Airport to the Wellington Airport with as little as 2 stops to limit the number of hops that we want our graph to take. Let's run this command and see what results we get. As you can see from the data, we've identified 5 routes from Austin to Wellington with 2 stops in between, such as Austin to San Francisco to Auckland to Wellington, or Austin to San Francisco to Melbourne to Wellington. What does this look like as a graph? As a graph, let's run this command again with the visualization feature turned on. And as a graph, you can see my starting destination is Austin and my ending destination is Wellington and all the airports that connect the two. You'll see some numbers between the edges as well, and these numbers represent the total distance between the edges so that you can calculate the shortest route possible and fly accordingly. Now that we can see what we can do with openCypher with our air routes dataset, let's try and run the same commands in our secondary database without loading data into the secondary database to see whether the replication from the primary database to the secondary database worked or not. For that, I'm going to go back to my Oregon AWS region, go to Notebooks, select a notebook which is already created and point it to my secondary database. Going to Neptune, I see the same options are available for the secondary database as well, such as visualizations, data science tutorial, machine learning tutorials, and such. I again go to the visualization piece and go to Air Routes openCypher tutorial. And this time, I use the endpoint of my secondary database, which is Global DB1 cluster 2. And I use the reader endpoint to connect my secondary database into my notebook in Oregon region. Again, I do the same thing. I replace my hostname and I run this command to set my notebook to my secondary database. Check whether this was connecting fine. Check the status of my secondary database to find that everything is healthy. And if I want to, I can modify some of these options. But let's continue with loading the data part. Now, this is the interesting part where I have not loaded any data into the secondary database, but I'm trusting the replication between the primary and secondary database for global database to work for me to query some of the results. Let's see, I want to get the first 15 airports that are present in this data set. As you can see, I can get a graph of the first 15 airports in this data set and what it looks like as a JSON file with the same airports, Kolkata Airport or Seoul Airport, Johannesburg Airport, and such. Let's run the same command that we did for our primary database, which was to find air routes from Austin to Wellington. Not changing anything. Running the same command, I can see that I can still find 5 air routes from Austin to Wellington using 2 stops. And what does that look like as a graph? As you can see, I can see a visual representation of what flying from Austin to Wellington looks like. Going from Austin to San Francisco to Melbourne to Wellington, or Austin to Los Angeles to Auckland to Wellington, with the distance between all routes specified so that I can calculate the shortest route. Similarly, where can I fly from Santa Fe, New Mexico nonstop? I get a list of 4 airports and I can look at it as a graph to look at what flying to the 4 airports look like from a graphical perspective. So this concludes our demo where we've showed you 1, how to create a global database for Neptune, 2, how to use Neptune's notebooks to connect to a cluster in your database, 3, how to load data into Neptune and how to use openCypher to query your database, and 4, how to query the same data from a secondary database without having to load data into it, because replication from primary database to secondary database takes less than 1 second. Thank you for taking the time to listen to this presentation and watch the demo. We hope you will try Neptune soon, and please let us know what you think. Thank you.